This portion of the example looks at measures of variability using SPSS. Now, unfortunately, SPSS does not calculate the index of qualitative variation, so that has to be calculated either by hand or in Excel. But it does do measures of variability for interval ratio variables. So suppose I wanted to calculate some measures of variability for the variable education. I would go to my Analyze pull-down menu, and then Descriptive Statistics, and then Frequencies. And I basically just select the variable that I want, education in this case, and I move it over here to where it says variables. And I can uncheck this box where it says display frequency tables, because I actually don't want to look at the frequency distribution in this case. And then I can click on statistics, and I can put check marks next to any measures of variability that I want to include, including the standard deviation, variance, range, maximum, minimum. I can also request the quartiles, or if I wanted to, I could put a check mark next to percentiles and add any percentiles that I want. So if I want like the 50th or the 25th percentile, I can add that. If I want the 75th percentile, I can add that as well. And then I click continue and OK. And SPSS will actually create a table of measures of variability for my variable. And so let's take a look at the results and see what we can figure out. So we see here the standard deviation is just over 3 years of education. We have a range of values from 0 to 20, or 20 values separating the maximum and the minimum. And so there's a fairly wide range of education in this particular sample. We can say that the difference between the most educated person and the least educated person is 20 years of education. And we see that the 25th percentile is 12, so 25% of people have about 12 years of education or less. The median is 13 years of education, so half the people have 13 years of education, the other half have more than that. The 75th percentile is 16, and so 75% of the sample has 16 years of education or lower, and the other 25% have above that value. Now you can see that the difference between the 75th and the 25th percentile here is 4 years of education. So that's our interquartile range. I could also create a box plot for this variable to show some of these same statistics. And so if I go to Graphs, Legacy Dialogues, and I go down here to where it says box plot, I can choose the simple box plot, and I can just use separate variables. And I click Define, and now I have to find my variable again, so educ, which is down here. I just move it here to where it says boxes represent, and then I can click OK, and SPSS should create my box plot. Okay, so here it is. Let's take a look at the distribution of education here in this box plot. And so we can see that it's almost a symmetrical distribution, although there is more values to the left tail than the right tail. Notice that this isn't a traditional box plot in the sense that this whisker doesn't go all the way down from the bottom of the box length to the minimum. Rather, SPSS flags values as being outlying. And so some of these values basically are values that have extremely low levels of education. And these numbers basically correspond to identification numbers. So case 21, case 248, case 512, etc. All of these have low levels of education. Now, disregarding the outliers, it's an otherwise symmetrical distribution, almost. It looks like the median's a little bit closer to the first quartile than the third quartile. So this is somewhat of a right-skewed distribution. And so we see the majority of cases are sort of towards the low end, at least in terms of the middle 50% of the data. And the median's not quite exactly in the middle. And so we see that the first quartile is a little bit closer to the median than the third quartile. And then this basically shows us the maximum, and this shows us the minimum when we don't consider the outlying observations. Now, what if we wanted to do something like this in Pspp? Well, unfortunately, Pspp is a little bit more limited. But if I go to Pspp, I can do something very similar to what I've just done. So if I go to Analyze, Descriptive Statistics, and then Frequencies, I can just find my variable, educ. I can move it over here where it says variables. And then down here where it says statistics, I can just put check marks next to any statistics that I want, like the standard deviation. I can choose the minimum and the maximum if I wanted to. I have a variance. I can put in the range. And unfortunately, I don't believe that it has percentile, so it's a little bit limited in that sense. And click OK. And we go to our output window. We can see that SPSS has created PSPP. I'm sorry, has created a frequency table, and it has a table of measures of variability. And so again, we see that we have a standard deviation about 3 years of education. The range is 20, indicating that 20 years of education separate the person who's least educated from the most educated. And consistent with that, we have a minimum of 0, a maximum of 20. Now, if we wanted to figure out the quartiles, we could easily do that as well. We just have to look at the cumulative percent column. It looks like 12 is the first one to include 25%, so 12 is going to be our first quartile. The 75th percentile looks like it's 16 because that's the first to include 75%. And so again, 16 minus 12 gives us 4 years of education. That's our interquartile range. And unfortunately, PSPP doesn't make box plots. So it looks like if you want to make measures of variability, SPSS seems like the better choice than PSPP in this case. But both do a pretty good job of some of the basic statistics, like things like the standard deviation, the variance, the range, the maximum, the minimum, and so forth. Advancing this detailed example forward just a little bit, suppose that we wanted to create separate measures of variability for some subgroups within our data set. So suppose that we wanted to, for example, make measures of variability of education separately for men and women. How would we do that? Well, basically, we could start by making a box plot. So if we go to Graphs, Legacy Dialogues, and then Box Plot, we can make a simple box plot, and instead of using summary of separate variables, make sure the radio button next to summaries of groups of cases is highlighted, and just click Define. Now, we're going to use our two variables in this case. We're going to look at education, and we're going to look at separately for men and women. And so we have to find education first here. And once we've found it, we can basically just move education over into this column like I've done here. And then second, we need to find our second variable, sex. And once we've done that, we move sex here to where it says category axes. And so the way that this is set up, we should have our variable in the variable box is education, and category axes should say sex. And then we'll click OK. And if we kind of zoom out, we'll notice that SPSS has created separate box plots for both men and women, but it has put them on the same axis. And so basically, if I zoom in here a little bit, I can see that I have a separate box plot for men and for women. And if I look at the basic pattern, I see that it's pretty similar for both of them. I can see both have the same maximum 20 years of education. They have the same 75th percentile, which looks like about 16. The median looks like it's about 12 for both of them. The first quartile is sort of close to 11. If we don't consider these outlying cases at the bottom here, the minimum would be around 4 years of education, although the true minimum is 0 because both men and women have somebody with 0 years of education. In terms of the overall pattern between men and women, the distributions are virtually identical. And so you can see that both have a kind of a slight positive skew because the median's a little bit closer to the left tail than to the right tail. So we've got this sort of long tail here with people who have slightly higher levels of education, while we have more people here that have sort of low levels of education. Now, what if we wanted to actually create measures of variability separately for men and women? How do we do that? So, first of all, we can split the file by going to Data, Split File. And we can split the file separately so that it does the analysis separately for men and women. And so if we just go to Compare Groups, choose our variable, move it over here to where it says Groups Based On. After we run this command, all the analysis that will be run separately for men and women. And if we ever want to undo this, we can just go back here and make sure the radio button for Analyze All Cases is selected. But we don't want that in this case. We want to compare the different groups. So we're going to compare the different groups separately for men and women by putting sex here. We click OK. And then we go back to our analyze, descriptive statistics, frequencies. And again, we can run our frequency distributions or our statistics here for education. And all the ones that we've chosen already are still highlighted. And so we click OK. And notice that this time, SPSS has actually created two tables, one for men and one for women. And so we can kind of compare the two. We can see that, for example, the standard deviation for education is slightly higher for men than for women, but they're pretty close. The range for men and the women is the same. It's 20 years of education. It looks like the quartiles are pretty similar too, almost identical, in fact identical. So the 25th percentile is 12 for both. The median is 13 for both. And then the 75th percentile is 16 for both. So the interquartile range is going to be the same. That is, the range of the middle 50% of the data is about 4 years for both. The true range is going to be the same, 20 years. And so these distributions look very similar to each other. Now, Pspp has some of these limited capabilities as well. So it won't make a box plot, but if you go up here to data, split file, it will allow you to split the file and to do the analysis separately for men and women. And so it'll bring up a dialog box like this one, and you can see that you can basically compare groups, do it separately for sex, and you can, if you hit OK here, it'll do all the analysis separately for men and women, just like we did with SPSS, and you should get pretty similar results. So really, like, either one of these is a pretty good choice. Obviously, the box plot is much better in SPSS than PSPP, but both are good for looking at measures of variability, whether it's for a single sample or for subsamples. Both packages are pretty adept at making these various measures.